myself SB Power, lecturer in Electrical Engineering Department, KK Polytechnic, Nasik. The name of the topic is types of transmission line and the different effect. So, as we know that when electrical energy is generating in the generating station, that electrical energy is transferred to the different parts of the country with the help of the transmission line. For that purpose, basically transmission lines are very important factor. So, in the last last chapter, we have to study about the different components of the transmission line we have to discuss. Before starting this here, we have to discuss types of the transmission line. Transmission lines are classified into three groups. First one is the short transmission line, medium transmission line and long transmission line. So according to the what is my short transmission line? The short transmission lines is nothing but the voltage level, and there are two factors which is decide the transmission line characteristics. What happen in the short transmission line? Distance is 0 to 50 kilometers. Means what happen for the short transmission line? The distance is 0 to 50 kilometer, and the voltage level is near about 33 kV, 11 kV and 22 kV. These are the voltage ranges for the short transmission line. The second type of the transmission line is a medium transmission line. What is my medium transmission line? Medium transmission lines are the lines in which varies the distance between 50 kilometer to 250 kilometers. The voltage level is 50 to 250 kilometers. Between this, the line is classified as a or known as a medium transmission line. How means which is the voltage level? The voltage level above 66 kV to 66 kV, then 132 kV, 220 kV. These are the short transmission line voltages. Up to 220 kV, these voltages is nothing but the medium transmission lines. Then what is meant by long transmission line? Long transmission line in the form of distance, the distance above 250 kilometer lines is called as a long transmission line. Voltage level means it may be the 500 kV voltage, it may be 1000 kV voltage, it may be 1500 kV voltage. So these are the long transmission line. Generally what happen? Long transmission lines are useful for the grid circuits as well as for the national grid to grid connectivity, and medium transmission lines are commonly useful for the transmission of electrical energy from generating station to the different part of the countries. But what happens? This short transmission line is useful for distribution of electrical energy in the rural areas as well as in the small cities. Then which are the different effect? Generally these are the two effect which is very important in the exam point of view. First one is the skin effect, second one is the Faraday effect. What is meant by skin effect? This skin effect is the property of the conductor. This is the property of the conductor related to the alternating current. When alternating current is flowing through any coil or conductor, what happens? The tendency of the alternating current to concentrate near the surface of the conductor. That effect of alternating current is called as a skin effect. Generally, in this skin effect, there is no uniform distribution of voltage or current. So, in this case, what happens? The current is not uniformly distributed here. So, due to which, what is the drawback of this effect? The drawback of this effect is that generally the heat which is transmitted, the current is concentrated near the surface of the conductor. Means what happened? Due to this concentration, generally heat is generated here, and there may be the breaking of the conductor, insulation maybe takes place. On which factor? What happened? This skin effect is completely absent. In the DC circuits. When the DC current is flowing through the conductor, what happens? There is a uniform distribution of the current. On which factor this skin effect is depend? This skin effect is directly proportional to the length of the conductor, type of conductor, frequency of the conductor, and the voltage level, how voltage level which is flowing through, type of voltage which is flowing through. It may be AC or it may be DC. So question on this topic is like this: define skin effect. On which factor skin effect is depend. So this is very important in the exam point of view. Then second one is Fahrenheit effect. So this Fahrenheit effect is also very important in the exam point of view. Why? This in the Fahrenheit effect, generally there are two very important things. What happen when we have to study the different component of the transmission line? There are three components of the transmission line: resistance, inductance, and capacitor. So see here, this Fahrenheit effect is occurs in the long transmission line commonly. In this effect, in the long transmission line, the effect of resistance, effect of current, effect of inductance, and effect of capacitance is considered. In this, due to these three effect, due to resistance, due to resistance, inductance, and capacitance, what happen? As we know that according to AC fundamental, Z is equal to R plus JXL, where Z is impedance, R is the resistance, and XL is the inductive reactance. For the long transmission line, Z is equal to R plus J, XL plus XC, where XL is a inductive reactance and XC is a capacitive reactance. Means what happen? Z is depend upon inductive reactance and capacitive reactance, and this effect plays an important role in the long transmission line. In this case, what is meant by Fahrenheit effect? In the Fahrenheit effect, generally receiving end voltage is greater than the sending end voltage. Receiving end voltage is greater than the sending end voltage due to the voltage drop in the resistance, voltage drop in the capacitor reactance, and voltage drop in the inductive reactance. So for that purpose, if the voltage sending end voltage is VR, Vs, and the receiving end voltage is Vr, then what happen? Receiving end voltage Vr is greater than the sending end voltage. This effect of the current, this effect is called as a Fahrenheit effect in the long transmission line. So this design of the long transmission line, it is very important. How to overcome this Fahrenheit effect? How to overcome this Fahrenheit effect? Generally, Fahrenheit effect can be overcome by using the different type of standard conductors like ACSR conductors, or it may be we can make the transposition of the conductor. For that purpose, we can remove these two effects. Fahrenheit effect can be removed with the help of transposition of conductor or by using the different parameters. Minimize by using ACSR conductor or transposition of conductor. What is meant by ACSR conductor? ACSR conductors means iron core and steel reinforced means ACSR conductors. In this conductor, if there is a 6 conductors in one conductor or in one core, what happen? At the center there is one conductor which is commonly made up from steel material, and remaining 5 conductors. If consider in one core, if there is a 6 conductor, if it is there, out of that 5 conductor, it may be the aluminum conductor, and the second one conductor is made up from the copper, which is made up from steel, due to which the weight of this conductor may be increasing, due to which this type of conductor is known as ACSR conductors. Due to this ACSR conductors, what happen? The total voltage drop in this conductor, sag and all these parameter, efficiency and all these parameter is increasing in these units. So these ACSR conductors can be minimize the Fahrenheit effect as well as skin effect. Then second point is the transposition of conductor. What is by transposition of conductor? So here this is very important factor in the transmission line. Transposition of conductor is very important factor in the transmission line. Generally what happen? R, XL and XC, these are the 3 factors. But in the long transmission line, XL and XC plays an important role. So in the short transmission line as well as in the short transmission line as well as medium transmission line, effect of inductance and effect when calculation of effect of inductance and capacitor is neglected. But in the long transmission line, when we have to make the calculation for efficiency and regulation of the transmission line, this effect is considered. This effect of XL and XC is considered. And what is my transposition of the conductor? Transposition of conductor is nothing but for after 250 kilometer, position of the conductor may be changed after some few kilometers. That is nothing but if the conductor, if in the first if it is RYB, in the second case it may be the YBR, and in the third case it may be BRY. Means what happened after few kilometers, the position of the conductor it may be changed. Position of the conductor it may be changed. Means what happened, the conductor which is at the top, after some kilometer it may be at middle, at the some time it may be at the next time it may be at the ground, or it may be the next place. Means what happened, the effect of this inductor may be inductance may be minimized. This type of effect of the transmission line is called the transposition of conductor. So the transposition of the conductor, it is commonly useful for the different type of units. It may be in, consider the diagram. In the first case, the conductor position it may be the RYB. Then in the second stage it may be YRB, YBR, and in the third case PRY. Means what happened, the effect of inductance may be reduced, and the total system. Means what happened in the after first 250 kilometer, the first phase of the conductor it at the top, in the second after some kilometer it may be at the middle, then it is at ground level, or it may be at the third position. Then this sequence may be changed due to the transposition of the conductor. Total system or the effect of inductance may be minimized. The first conductor which is coming in the combined with the second conductor, it may be also minimized. So this transposition of the conductor means what happened, the changing of the position of the conductor after some kilometers. So that type of positioning is called the transposition of the conductor. Generally, this transposition of the conductor is commonly useful to minimize the inductance in the transmission line, and it is commonly useful for the long transmission lines. Thank you.